Okay, so today gonna talk about the dura mater and the epidural space, and for this lecture, I'm gonna use this diagram, and I already sketched it yesterday, so for me it's pretty easy to just complete this diagram. Now, so what do we have here? We have this part here that is before I start to ink over the sketch, I would like to talk a few things about the dura mater and the epidural space. Okay, so dura mater, well, you probably know, is the outermost layer of the meninges. If you are following my lectures, you already know that this meninge is the outermost. Okay, and I already mentioned that protects the spinal cord and provides structural support, and this within the vertebral canal, which is something that if you have the model or if you have the cadaver to analyze, it will be clear. Now, the dura mater, it's separated from the walls of the vertebral canal by a space known as the epidural space, and the dura mater also extends into specialized structures around the spinal nerves as they exit through the intervertebral foramina. Okay, so dura mater. Let's do. Let's just paint this part here. Sorry. Dura mater. This is the part of the dura mater. Okay. And let me just complete here and here. Okay, the dura mater, you know, but repeat to persist to learn. The dura mater is tough and is a fibrous membrane and protects the spinal cord. Okay, this is I believe that you already know all of this, but it's better to repeat. Okay, and it's composed of dense connective tissue, and this dense the dura mater actually provides a mechanical protection against external force, and the outer layer, okay, is periosteal, while the inner layer is meningeal, and both contribute to strength and resilience. So this is the dura mater. Let me just highlight this part, label this part. Okay, this is the dura mater. Dura mater. If you want to review everything that I said, I recommend you to follow my YouTube channel, and there will be all the information related with each part labeled of this diagram. Now, what else? We have this part here which is the epidural space. Let me just, this one here is the epidural space. Okay, I hope you can see it. Pretty much that you can see it. Okay, this is the epidural space. Epidural space, and the epidural space is located between the dura mater and the walls of the vertebral canal, which are here, okay? The walls of the vertebral canal. And the epidural space, this space contains a semi-liquid fat and the internal vertebral plexus veins, actually. And when I start to illustrate the veins, the arteries, it will be clear. But we still have a bit of time until to get there. And this space basically serves for severe. It will have a severe important functions, especially related with shock absorption. So, which actually is where the same liquid helps cushioning the dura mater and protecting from the contact with the bone walls of the vertebral canal. There is also the vascular supply, where the internal vertebral plexus of veins provides blood circulation to the dura mater and the surrounding tissues. And it's also an area where anesthetists usually administer anesthetics during procedures such as childbirth or surgery. It also allows medication to diffuse along the dura mater and block nerve signals, especially for some specific procedure, I might say. And this is the epidural space. And then we have the tubular prolongation of dura mater, which is this part here. Let me use another pen. This is the tubular prolongation of dura mater. Tubular prolongation of dura mater. Okay, so we have this part here, tubular prolongation of dura mater, and this part. So what will happen as the spinal nerves exit the vertebral canal through the intervertebral foramina? The dura mater extends into tubular prolongations, which we call dural sleeves. And these sleeves, in specific, these sleeves will surround the spinal nerves. And why? Well, they will in some way provide additional protection and guidance as they leave the spinal column. These dural sleeves help actually maintaining the integrity of the nerve roots and prevent compression or irritation in this area. So this is why we have these tubular prolongations of the dura mater. And then we have the posterior longitudinal ligament. The posterior longitudinal ligament. This one is quite interesting, but I don't think that I can cover everything related with this structure here, but at least I can give you a taste of the tubular of the longitudinal ligament. And well, oh sorry, let me just label this part. Posterior longitudinal and ligament. Okay, posterior longitudinal ligament. This ligament is strong, is fibrous, and is located along the posterior aspect of the vertebral body. Let me just see if I can find here a vertebral body to show you where exactly. Okay, I have this one. Okay, here is the vertebral body, and the posterior longitudinal ligament will be in this area here. Okay, pretty much what you see here in this illustration. Okay, and it's not part of the meninges, and it's actually loosely attached to the dura mater. What you will see is that this ligament, in specific, runs the length of the spine and helps stabilize the vertebral column by preventing excessive anterior displacement of the vertebra. When I talk about biomechanics, movement, and how all these things will behave in action, it will be clear. Right now is just the gross anatomy, okay? And if you want to know more about this, you need to, follow me. You're already here. Why not? So, let me finish this part, adding the vertebral body here, transverse process here, oops, a little sharp, and then spinal process, and then here the transverse process. Let me just think if I have anything else to mention about this part. Okay, so at the level of the second vertebra, sacral vertebra, which is around here, okay, the dural tube ends forming a structure called the filum terminale. I already mentioned about the filum terminale in another video on my YouTube channel, so I highly recommend you to have a look at the video. And the filum terminale is thin, fibrous strand that extends inferiorly from the end of the dural tube and attaches to the coccyx. And it basically helps to anchor the spinal cord and the dura mater to the base of the spinal column. So your spinal cord is not there floating, okay? This is important. Your spinal cord is not floating. And attachments of the dura mater. What I can say, dura mater is primarily attached to specific anatomical structures. Foramen magnum, which margins the margins of the foramen magnum is where the spinal cord transitions into the brainstem, and intervertebral foramina as well, around the openings through which the spinal nerves exit the vertebral canal, and the back of the coccyx via the filum terminale, which I already mentioned here, filum terminale here, and this is the anchor of the spinal cord, okay? And dura mater, let me just see back here, and dura mater, okay. Yeah, this is actually what I have to share. Okay, I don't have anything else. Everything that if I have to say something else, I will be just repetitive. So what I highly recommend now is that you take a moment to review the lesson. I will upload the video on my YouTube channel. You can check my YouTube channel is on my TikTok account. There is the link to my page, and there you can have a look at the video of this lecture, okay? And then yeah, that's it. This is what I have for you today. I really appreciate your time here with me. So see you tomorrow at the same time for for another lecture about neuroanatomy. Yes, let's go. See ya. Don't forget to follow me. See ya.